All right, so lesson 5 had a couple problems at the end of it, and I'm going to go ahead and go through those pretty quickly. So we see the first one is the ball thrown horizontally off of a tall building or cliff, and we want to know with a particular speed, and we want to know how long does it take the ball to hit the ground. Well, how long an object is in the air is determined by the vertical component because we do have gravity acting on an object in the vertical direction. Because we have no acceleration in the x direction, if we didn't have gravity, it would continue to go in the x direction forever. So we're going to go ahead and start with A. So how long does it take the ball to hit the ground? Well, let's go ahead and sketch the problem. All right, so I have my lovely building, my lovely ground. We're going to go ahead and assume that this little corner down here is going to be my x naught of 0 meters. It's also going to be where my ball ends up when it hits the ground. So that's also going to be my y, not my y naught. All right, and that's also 0 meters. My ball does start at the top of that cliff. So this right here is going to be my y naught of 100 meters, since that's the height of my cliff or building. And we do see the fact that the ball does have an initial velocity of v0x, that is 54 meters per second. Why was I able to put the x right there? Well, I was able to put the x right there because it specifically said that it was thrown horizontally. That means that this speed right here is entirely in the x direction. Right? If my speed was initially entirely in the x direction, well, what was y naught? Well, that is 0 meters per second. Right? We already know, because of what we know about projectile motion, that ax is going to be 0 meters per second squared and ay is going to be 9.8 meters per second squared. This is going to be down, and because of the way I set my conventions up, I went ahead and said that up is positive y and to the right is positive x. So that means that this 9.8 meters per second squared does need to be negative. Right? From here, I see what I have and what I don't have. Right? And I'm specifically looking for how long does it take to hit the ground. So I want to know t. Right? From here, I can see I know my initial y velocity. I know my initial height, my final height. I know my y acceleration, and I'm looking for time. So I can pull this equation. Right? And we are able to zero out several of these numbers. That helps make our math a lot easier. So my y is 0 because it hits the ground. My initial y velocity is 0. Right? That means I'm left with this term, and that's it. I'm going to go ahead and skip to what this equation looks like. Solve for t. All right, sorry, I almost forgot my negative there. So I have my negative 2y0 over ay. I am then able to plug in all the numbers that I know. All right, so that's that negative 2 times 100 meters divided by that negative 9.8 meters per second squared. And it is important to keep track of this information. Otherwise, you are going to end up with a negative inside your square root, in which case imaginary numbers are going to give you all kinds of issues. And we do see that the time that this is in the air is 4.5 seconds. All right? And there are a lot more digits to this, but for the sake of this particular part A, we can go ahead and round it to 4.5 seconds. The next thing we're going to look at is part B. How far from the edge of the cliff does the ball land? Well, when we're looking at how far from the edge of the cliff the ball lands, we're looking at this distance here. Well, that means we're looking for XF. All right. So we know we're looking for our final position. We know our initial position. We just found time. we know our initial x velocity, and we do know our x acceleration, right? So we are then able to pull that same sort of equation again, but in this time in terms of x. So x is equal to x naught plus v x naught t plus 1/2 a x t squared. All right, we're able to again cross some figures out. This x naught here goes away because it's 0, and because our ax is 0, this whole term goes away. So we are left with x is equal to vx naught times t. Alright, so we're going to go ahead and multiply our 54 meters per second by our 4.5 seconds. However, you should be using the unrounded number for this particular problem. And when I use the unrounded number, I get 244 meters. All right, so it does land 244 meters from the edge of the building or the edge of the cliff.